Hello students. So we now begin with numerical problems on the design of clutches. I hope you all have gone through the introductory video that was previously posted and you are aware of the torque carrying capacity of clutches and so on. We will now look into solving some of the design problems. Most of the problems that I will be solving are taken from VB Bandari textbook. So let's look into the problem statement in the next slide. Okay, so the problem statement is as follows. Uh, a plate clutch consists of one pair of contacting surfaces. The inner and outer diameters of the friction disk are 100 and 200 mm respectively. The coefficient of friction is 0.2 and the permissible intensity of pressure is 1 Newton per millimeter square. Considering both uniform wear theory and uniform pressure theory, calculate the power transmitting capacity of the clutch at 750 rpm. So this is the problem. This problem falls under the category of single disc or single plate clutch. Uh, if you will look at the data, they have specified the inner and outer diameters of the friction disk. Coefficient of friction is also known, and the permissible intensity of pressure is 1 Newton per millimeter square. And they have asked us to calculate what is the power that can be transmitted by this clutch at 750 rpm speed. All right, so let's go ahead and solve this problem. Now you know that to actually calculate the power, you need to know the torque, right? And for torque, you have already derived formulas. If you have watched the previous video, you know that for both uniform wear and for uniform pressure, there are separate like equations for the torque that can be transmitted. So using those formulas, we will determine the torque. And once you know the torque, you know that power can be directly obtained as 2 pi nt by 60. All right, so that is how we will be solving this problem. So let's look at the solution in the next slide. All right, so let's begin to solve this problem. The data, as we know, is given as inner diameter is 100, outer diameter is 200 mm, and coefficient of friction of the liner is 0.2. The maximum intensity of pressure is 1 Newton per millimeter square, and the RPM is 750. All right. So in the question, they have asked us to determine the power by taking into account both uniform wear and uniform pressure theory. Now let us begin the solution by initially taking into account uniform wear theory. Now for uniform wear, we know from our design data handbook, we have equation 13.9d, right, which will give you the axial force needed, right? Now all the parameter in this formula is known to us. Substitute and you will get the axial force as 15,707.96 Newton. All right, so you know the axial force. You can now go ahead and calculate the torque carrying capacity. Now torque we know is obtained from like equation 13.9e, right? Where you have torque as 1 by 2 times mu into axial force into the mean diameter dmw, and we know that for uniform wear mean diameter is the average of the inside and outer diameters, and the average turns out to be 150 millimeter. So substituting everything, we can solve for the torque, and we get the torque as this value here. All right, so once you know the torque, you can then calculate the power. Okay, power in kilowatts can be obtained as 2 pi nt by 60 into 10 power 6, right? RPM n is known. So substitute that and you will get the power in uh, kilowatts. Therefore, the power that we get for uniform wear theory is 18.5 kilowatt. All right, so this is how we uh, determine the power that can be transmitted by the clutch. All right, so this was for uniform wear. In the next slide, we will look at uniform pressure. All right, so now let's look at for uniform solving for power using the uniform pressure theory. Now, according to uniform pressure, we have from our handbook equation 13.9a, which gives you the axial force. All right. So, substituting all the parameters, we will get the axial force as 23,561.94 newtons. Right. So we can solve for the torque now, and torque we know from formula 13.9b is basically force into a radius. We also need to take the friction force into like account here, and the mean diameter you will get from the same 13.9b formula here. Now remember, we had derived this formula in the previous video. uh, Solving for the mean diameter, we obtain it as 155.56 millimeter. So you know the axial force and you know the mean diameter. Substitute it into the torque formula and you will solve for the torque, and you will get the torque as this value here. Right. Now, knowing the torque, you can now calculate for the power similar to the previous case. And you see that the power that we get is 28.78 kilowatt. All right. Now, if you will look at the power equations, sorry, the power values from both uniform wear and uniform pressure theories, you see that uniform pressure theory predicts a power transmitting capacity which is significantly more than that of uh, uniform wear theory, right? So, but we know that uniform pressure theory is largely applicable for new clutches, right? Whereas uniform wear theory is applicable for clutches that are in service, that has undergone a certain degree of wear. All right. Therefore, what we can observe from these results is that uniform pressure theory will overpredict the power for a clutch that is say subjected to wear, right? Therefore, to be on the safer side, it is always better to use uniform wear theory for uh, clutches that are in service. All right. All right. So this was problem number one. We will stop here and we'll move on to problem number two in the next video. Thank you.